working at least 2 jobs for the last 11 years of my life. So I also do a lot of internal evaluation, actually trying to demonstrate that our materials have value. I've been doing some form or fashion of evaluation stuff for about 5 or 6 years. The most relevant stuff that I'm going to be talking about today came in my 2 years at SHOT, a year in between Intel and SHOT while I was doing independent consulting, and about 2.5, 3 years of my last 3 years over at Intel. And that has to do with standard operating procedures. In the world of high tech, you got to have specifications that dictate all of your actions, whether it's operating the tools, processing the wafers, or fixing equipment. You want to do things according to a spec. Why do you think having a spec is important?
So that you can maintain consistency?
Absolutely. That's a perfect answer. The word I like to use is standard. You want to have a standard, all right? I went ahead and put 2 pieces of blank paper in front of you, all right? My boy, he's learning how to play guitar, and I'm doing this game with him. I know what songs he's learning, and I know what artists he's really into. So he'll be plucking along on his guitar, and I'll say, "Hey Nathan, Santana on Demand," and I'll get and just on demand though is the funny part. He'll switch. He'll just switch gears and do it. So paper airplane on demand. You have 60 seconds. Give me your best paper airplane. Funny thing is, I hope they keyed into the word best. So if I get one in like 10 seconds, it's probably not the best. If they're still working at 65 seconds, I didn't get my minute. So I'll give them some time marks along the way. That's 30 seconds.
You got 30 seconds left. Wow.
No pressure. 20 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right. Origami flower on demand. No, I'm joking about that one. I'm joking. We snagged it. Very cool. Very cool. Very cool. Very cool. This is awesome. This is what I love to see with on demand. What's the difference between this one and this one?
Bigger.
Bigger. Slick. These are similar. Still differences though, right? What's the difference?
The
The wings. One's a little bit smaller. Not an issue. What's the difference between these two?
good bit in the way they'll fly.
Did you see that video in somewhere in the UK? Somebody threw an airplane from like the one of the boxes or something. This airplane just flew for like ever across the whole field. That was cool. I thought about that when I was prepping for this. So, not sure how these are going to fly. And it doesn't matter. The big difference is I told you guys to make a paper airplane. If I was if I was a sales representative for Boeing, do you think I'd be able to sell 4 different models like this? Now, a lot of that is my fault, right? I didn't give you any instruction. I put you on the spot. I mean, philosophically, we could talk about why we didn't get the same results. But if I was in industry and I wanted similar results, standardized results, would this ever fly? They're all different. I want standardized, I want repeatable, I want dependable, reliable materials, whatever it is. If it's a 1-minute product, or if it's a product that takes 120 days to make, to go through a manufacturing line, one error within that 120 days induces so much waste into your line, into your manufacturing line, that they'll never be able to sell it. It'll be full of defects. Okay? So that need for standard is incredibly important. How about anybody interested in maintenance, whether it's automotive maintenance or high-tech tool type stuff?
Yeah.
Cool. Why is standardization in the way you do maintenance important?
What do you mean, like process-wise, or?
Equipment maintenance. If I'm fixing a car, let's just do the general shop. If I want mechanics that'll fix my car, how is getting it done the same way every time a good thing?
Something gets messed up, it's easier to troubleshoot.
Uh-huh. Good.
That's one of the bigger things, I think, with machines. From personal experience, anyway.
How's this one for a little story? I just needed a couple of tires put on my car, and went over to a reliable tire manufacturer, tire installer, and asked for a couple of tires. They told me they'd have them in stock within a day. They missed because of the snow day last Friday. Then they didn't know where it was, so it got lost. They couldn't get information to me on Saturday and Sunday because the place that shipped it, they weren't open. So then I go in on Monday, and the guy that I was dealing with, he wasn't there, so they didn't know what this guy had done to help me get the tires. So, and this was an expedited type deal, so to say. I get a call on Tuesday saying, hey, your tires are in. Meanwhile, back on Sunday, my tires were looking really bad. So I went over to Walmart. I was like, hey, I need 2 tires put on. I got 30 minutes while my wife's grocery shopping. Can you do it in 30 minutes? They were like, yup, empty bay. I was like, cool. I was like, at the end of the 30 minutes, if you're not done, I'm gonna let you deal with my wife. Is that okay? They were like, yup. So I was like, okay. So 30 minutes, they had my tires put on. That was reliable customer service. It left me with a feeling that as a customer, I got what I paid for. I don't care about some of the other expenses that they put into having those tires there. Somebody had stocked them. I wasn't really paying for that. But I wanted those tires on within 30 minutes. They were able to do that for me. So big differences between customer satisfaction and customer dissatisfaction. So let's go back to lean again. We had the definition. Repeat what you said about the definition of lean manufacturing.
You're trying to do the task or whatever you're trying to produce, or you're trying to accomplish what your business is set out to accomplish with the minimum amount of materials and time and resources necessary.
Very good. You just added a few things to it too, and that definition is getting even better. All right, The one last thing I would add to that is from whose perspective? Everything that he just said, when it's from a lean perspective, it's supposed to be from your customer's perspective. Okay? Who define a customer for me?
The person who buys your product?
Good. The person who buys your product? Is your product always, I'm sorry, is your customer always external?
No.
Tell me what you mean by that.
Well, I know at Honeywell, the different departments would build test equipment for other departments.
Perfect.
So
So you're all within the same organization, but your customer, absolutely, that's what I was fishing for. On a manufacturing line, this gets really important. When you know who you're delivering to every day, your downline is expecting a particular product on a particular timeline in a particular manner so that they can do what they need to do to add to the product. Okay? This is good. This is good. One more important element. My 30-minute tire job, that sounded pretty good, right? So you're in NASCAR, and you come into the pit because all of your tires are worn. And you're on like your last cycle and you're winning. You're winning by like 30 seconds. How's that 30-minute tire job gonna go for you? No. All right, what's the solution in NASCAR? Number one, what's it called? Pit crew? A pit stop performed by a pit crew. Perfect. Who's the customer? The race car driver. Very good. All right, race car driver pulls in. Somebody describe a pit stop for me. Just a general, what happens on a pit stop?
the car comes in, they replace the tires if it needs it, gas, and I know some of the Formula One guys, they actually plug a computer in to change the diagnostics and whatnot.
Very good.
On the machine.
Mm-hmm. How many people are on a pit crew? It varies. It varies.
6 or 8.
Yeah, about 6 or 8. You don't see much more than that. Otherwise, you're going to get people tripping over each other. You don't see fewer than that because usually on the pit crew, there's a person or two just on each tire. So let's just stick with the tires. How long does it take for a tire change in NASCAR? It is
like 10 or 15 seconds.
It's fast. It's like 3 or 4 seconds to unbolt it, 3 or 4 seconds to put the tire on, 2 or 3 seconds to rebolt it. And you got 2 people working in unison. So if Walmart was geared up to do a pit stop, and I said, you guys got 30 seconds or you got to deal with my wife. Why can't I expect that? Why can't I expect that kind of service from Walmart?
There's probably only one guy that's going to change your tires.
Yeah, that's one. Absolutely.
They don't have the equipment necessary, and your car tires are not set up for that sort of changing speed.
No. Very good. How much would it cost Walmart to provide that level of service? They can't even man their registers.
Yeah.
How? Did I say that on tape? Okay. Walmart, always low prices, always. Providing a pit service doesn't fit in with Walmart's core competency. Providing a pit service for NASCAR, that's a core competency. They know exactly what kind of oil you need. They know exactly what kind of diagnostics they have to plug in. They've got the tires ready to go. Everything is staged. All right? So, a lean operation then is all of what you said. The elimination of any sort of waste, such as to make a product or a service as effective and as efficient as the customer is willing to pay for. In big qualification at the end there. If I want that kind of service at Walmart, I can't afford that kind of service at Walmart. It won't happen. All right, but they met my 30-minute expectation. Okay, so I was willing to pay for what I got. It's going to be a bit of a painful analogy, but how do you think this might work out in, say, maintenance on a $120 million piece of equipment on a semiconductor manufacturing line that by design is what we call a factory constraint? What a factory constraint is, you can think of it in terms of a bottleneck. You've got all of these tools that can produce all of these wafers, all right? But it gets into one area, that limiter is a constraint. You will only get out what the constraint allows you to manufacture. 100 in, 2 out, fastest you're ever going to be with that one tool is 2 out. That's why we build extra capacity with extra tools, but it's called a design constraint. Or you go ahead and you make this design constraint as effective and as efficient as humanly possible, all right? $120 million piece of equipment is a lithography tool. I'm sure they've gone up by now too, and the higher size the wafers that you're manufacturing, the more expensive it's going to be. The more high-tech, the faster that it'll do the lithography operation, the more expensive, the more valuable these tools are going to be. I don't think it's much of a stretch to say they're probably always going to be the design constraint. So what happens when this thing has to go down for maintenance?
Everything shuts down.
Effectively. So what do you think the priority of the factory manager is going to be? Get that tool back up. Does a factory manager that takes that tool down for a quarterly PM, a once every 3-month maintenance that has to happen, does he want that tool down for an unpredictable amount of time? If it's 3 hours, he wants to know that it's 3 hours. And as technicians, you don't want your factory manager telling you, you're going to have to deal with my wife effectively. And the factory manager is going to be different, right? The factory manager is going to say, 30 minutes, 20 minutes. Probably not, because effectively, the technicians that are doing this kind of work, they know what they're doing. They're more like a pit stop crew, all right? How did I introduce this? Why are they more like a pit stop crew? What do they have at their disposal?
They'll need to get specialized tools and equipment to.
They do, but what are we going to talk about specifically today? Standard operating procedures, right? Or a spec. All right. So, Jim, you're telling me that in industry, people have this spec and they follow it letter by letter, step by step. Is that what you're telling me, Jim? That's got to be one of your questions. They're accountable to whatever's written on that spec. They don't necessarily follow it. Operators don't have their spec in hand while they're... So who might follow the spec to see what's happening while a maintenance is being performed?
Somebody doing it for the first time?
Somebody doing it for the first time? Absolutely.
Can I talk to you out here?
Sure. I've got answers today. So if you look at any Toyota production line, this is really cool. You got 60-second jobs. That's all that's happening. That line is moving, and sometimes the line slows down or stops so that a job can happen. At other points, it speeds up because they've got 3 jobs that might happen within that 60 seconds. But the job at a Toyota production line, and it's actually something like 57 seconds the last time I heard about it. So a seat gets installed in 57 seconds. Dozen rivets at this particular job gets done in 57 seconds. 100 rivets gets done in 57 seconds because they're all localized. So those 12 rivets, they might be harder to reach. But the job doesn't get broken. You don't do it in less than 57 seconds, or you don't do it in more than 57 seconds. If you do it in less, it's okay. You have time to whatever. But it's called a takt time. All right? So takt time is the standard. Why is takt time important? In this grand scheme of this maintenance stuff and this operations and standard operating procedures, why is knowing that takt time important?
Keeps the manufacturing on time.
Perfect. Keeps accountability to know how many products we can do and how long, to what standard of quality, and it becomes a fine-oiled machine, right? So back to the specs. There's somebody that is doing their work, and the spec is actually posted outside of the workspace. So as you were building your paper airplane according to a spec, I ought to be able to look at the spec, observe what you're doing, and see where you are on that spec. So the specs, once they're mastered by the operators or the technicians or the mechanics, they're just used to check on for accountability, to see as quality checks. So having the spec in order to ensure quality is one of the keys. What do you think? One of you mentioned having a spec available for the first-time person. What's happening to the first-time person? Just think in the broadest possible terms here. You're being thrown on to do that job. Install the seat in 57 seconds. How's that going to go for you? what do you need before you can do that job in 57 seconds? Experience what? Training. So these documents that I'm going to show you, these are actually training-oriented documents. At their root, a standard operating procedure isn't really a... I want you to hear this. If there was something that was quizzable or testable, which is not from me, but I don't know what Matt might ask for follow-up. A standard operating procedure has two purposes: to follow up on quality and to train against. If you can't do either one of those, really the standard operating procedure isn't serving the purpose. Okay? So I'm going to be getting into some detail about standard operating procedures, but then I'm going to be talking about it from a perspective on how to use it for training as well. Okay? All right, let's go ahead and get into this.
Next slide.
Please. So, a little bit of history. This approach that I'm going to show you, you ever see a woman flexing her bicep from pictures in the 40s? Does anybody know her name?
Rosie the Riveter.
Beautiful. Good job. We were at a conference in San Diego, and we were walking by, and we saw a picture of Rosie the Riveter with a face cut out. So I was able to put my face into the Rosie the Riveter sign, and ugliest Rosie the Riveter I've ever seen. Rosie the Riveter was a poster child for a wartime effort called Training Within Industry. And the phrase was, we can do it. This is World War II area. All the guys had been shipped out for military service. invading Germany, serving on the boats, the whole 9 yards, right? So the workplace was flooded with women and minorities. The time was different. So these women and minorities needed to be upskilled immediately, okay? So they utilized this concept called TWI, train within industry. The whole concept is, you're on the job. You gotta learn by doing this stuff, all right? There were no classes provided to these people. There were problems that needed to be solved. So the TWI approach, it's not a matter of schools or classes or lessons. It's an individual or a group working on a modern problem of output, quality, lost time, scrap, rework, maintenance, and working relations. I'm going to just briefly talk about working relations in a minute here, but suffice it to say that all of these problems of output, quality, and time to productivity, that's what was important, okay? So they actually used this training within industry job instruction worksheet. This is the model of it that I gave you. I gave you a blank template that we're going to be using. I gave you the artwork, the art wafer process, and I gave you a wafer handling job instruction. Do we have the wafers and stuff?
Yeah, they're in the back.
Cool. So back to the history of this. Within World War II, during World War II, these Rosie the Riveter folks came into the workplaces. They learned how to do their particular jobs within the military complex. I've got a picture. You know what IBM is, right? What did IBM start off as? What was IBM famous for making? Typewriters. Business machines, right? So they had converted a typewriting manufacturing line into a rifle manufacturing line. About 30 women made better rifles, faster, with higher accuracy on that IBM line than the rifles that were being put out pre-wartime from the best rifle manufacturers of the day. They did this because they learned according to this job instruction methodology. So let's go on to the next slide, Matt. Train within industry, it all happened between 1940 and 45. There were 600 companies that were monitored for effectiveness. Before I go into the results, please look at what the price of admission was. There had to be 25% reduction or increase in the quality or in the training reduction time or in the reduced labor hours just to be measured. So 25%, that's a full grade. 20% is a full grade in academic terms. If I could just push a button and become 25% better at a job that takes me 5 days, 4 days, now I could do it in 3. That's an awesome result. So that's just the price for admission. And then this was how many of those 600 did it. Check that out. 100%. So all 600 companies, there wasn't a fluke in that test. 100% of them reduced their training time by 25%. I never told you what I did at Intel. I was a training program manager. I was an instructional designer. I was a technician. And I was a manufacturing supervisor. 25% in any of those roles, I would look at as being awesome. If I could get my technicians, some of my technicians took 3 months, 4 months to train. If If I could take a person that would typically take 4 months and I could get them that done in 3, that'd be awesome. So this was the kind of results that this yielded. So next slide, Matt. So TWI, which was the program, Training Within Industry, it worked like a 3-legged stool. If you took any one of these legs away at the time, the stool would have broke. So at the center of it was job instruction, which was standardizing the work. Underneath that was job methods. The whole class, or the whole experience, taught people how to take a standard and improve upon it. And then job relations. All I'm going to say about job relations is you got to think in terms of 1940s. The human resource methods, the human resources as we knew it didn't exist. So I'm not an expert at this, but I've heard, I haven't validated this, so I'm just going to fly over this. I've heard that this actual job relations training was a forerunner to that modern HR field. So a lot of handling problems before they become bigger problems was taught within the job relations. Now, suffice it to say that the modern human resources has invalidated this 3-legged stool thing. Human resources, they're going to happen. Companies have policies, procedures. It is what it is. So all I really teach now is this whole idea of job instruction for the standard, job methods for continuously improving. How might those two be used with each other? Say I'm working a project and I want to make these standard. Where am I going to start with? Job instruction or job methods?
Job instruction.
Job instruction. Why? This is a really easy question. Why?
Because you need to have a standard before you can prove it.
Beautiful. You, my friend, have no idea how many customers or managers that I've worked for that have said something to the effect of, this is what I want. All right? And while you're at it, make sure you include this. And while you're at it, I want you to do this. And we need it in a month, but if you can do it in 3 weeks, excellent. Okay, what's the problem here? What's he asking me to do? Improve upon something before I even have an idea of the work that I've got to do to achieve the job, right? So this is just part of corporate America today. They're going to tell you all of this stuff that needs to be done, and they're going to assume that when they say make an airplane, you're going to make the airplane that they want. Okay? Doesn't work that way. So you use job instruction to get a standard, and you do job methods to get an improvement. Did I say 12 improvements? Did I say 100 improvements? An improvement, all right? And then once you get that job method in place, it becomes the new standard, right? So the last step of job methods is always to make sure that it's the new standard. All right, next improvement, next standard, next improvement, next standard. That's what they mean by continuous improvement. You're always improving, but you're remaining standardized. All right? Let's go to the next slide. So TWI is always in relation to whatever your current state is. So I usually use this slide, and I left it as I usually use this slide as like a bit of a selling point. You know, do you have a lean or an on-the-job training system in place, Are you making incremental improvements based on Lean and TWI principles? Embedding a Lean culture, it's an ongoing process. I usually give my clients the same kind of disclaimer I gave you, though. I'm not there to establish their culture. I am, however, there to standardize their work, and we bring it into what's called job instruction concepts. We apply what's called the job breakdown sheet for knowledge capture and training. That's what we're going to be dealing with today specifically, the job breakdown sheet. Job methods. A Lean culture is getting better a little bit every day, okay? That's beyond the scope of this class. We won't be talking about continuous improvement methodologies. We'll be sticking with the standard work from here on out. Next slide, please. So, this is the job instruction terminology. Everything that you need to know today is on this one slide. The good news is, everything you need to know today is condensed onto this one slide. The bad news is, everything you need to know today, I'm going to hold you accountable for what's on this one slide. All right? As I get you into some instructions and whatnot, this is what you're responsible for. You don't need to worry about taking notes. You've actually got everything. Yeah, everything that's on that template is right there. Okay? So if I'm going to hold you accountable to that stuff today, what do you think the best way to use that is going to be? If I ask you a question about what an important step is it breaking the law to use your document? Somebody made an interesting point earlier. The spec is used by people that aren't experienced yet. How do you get the experience? By using the tools that you got. This tool is meant to be used, okay? Refer to it. Don't feel like you're cheating. Now, having said that, you're not going to be a pro here in the first 10 minutes that you're using this either. So don't assume that I'm all good, I got this. Just keep on referring to it until you're very comfortable. An important step, anytime that you do something that progresses the work that you do, it's a logical segment of an operation. Anytime you advance the work, you're taking an important step. Anytime you change a product, you're taking an important step. So check this one out. You just destroyed somebody's life work. Just makes me feel miserable. Fold 1. I just advanced the work. That's an important step. Fold 2. Important step. Fold 3. Important step. 4, 5, 6, 7. That's a 7-step airplane. Okay? Nothing more, nothing less. Go ahead and equate it to changing a tire real quick. What do I have to do to change a tire? Okay, the nuts. Mm-hmm. Pull the tire. Oh, wait a minute. I need to lift the car.
Yep. Said that.
Okay. So yeah, good. So before you can do work, sometimes there's preparatory steps, right? So anything that it takes to do to get the job done has to be documented in the important steps. Now, let me give you some sage advice. And I know that sounds cocky or arrogant. There's no such thing as a perfect work instruction. All right? There is no such thing as a perfect work instruction. You can tweak these things, you can make them better. What's your goal? We have a colleague that we work with that always says, what's your goal? And every time she says it, I get this big smile. What's your goal? Right? Your goal isn't to have a perfect work instruction. Your goal is to get a job done in the most efficient, effective manner that the customer is willing to pay for. Your employer isn't going to allow you to work a job instruction until it's perfect. they probably want an 80 to 90% solution. And they want it on the floor yesterday. Okay? So, important steps, capture the ones that are the logical segments that make the most sense to move you forward. Okay? I want to start with reasons why. Reason why we do something. All of the training literature, all of the adult learning literature says that if adults understand why they're doing what they're doing, they'll have more respect for the job that they're doing and they'll care about it more. All right? So the reasons why may seem like the least important step while you're creating these work instructions. All right? But the more why you can give, the more meaningful it's going to be. Okay? Key points. Key points are the epic part of the work instruction. Key points is anything in a step that might injure a worker, make or break the job, make the work easier to do, and it's always that little point that if you can capture it, that's probably where your continuous improvement opportunities are going to come from. All right? So the key points are a very important aspect of this. Jim, injuring the worker, and I get this in industry, injuring the worker, that's part of our safety culture. That's important, Jim. Safety is important, Jim. Why isn't safety part of the important steps? Why isn't it?
Because it wouldn't enhance the word.
Exactly. Safety needs to be a mindset. It's extremely important. Safety is usually part of the corporate culture. Safety is usually part of the workforce and the floor culture. Safety is already paramount, all right? So it is important, but it's assumed that it's happening while the important steps are happening. But if there's a key point in there that is something that could injure a worker, you still highlight it in the key points, all right? I'll tilt my hat on something too. From a training method, key points get repeated more often than important steps or reasons why. You'll see that here in a little bit, but that's another reason too. If I'm trying to build safety into my culture, I make it part of my key points. All right. Make or break a job. What does that mean? What's something that would make or break a job?
Part that if you don't get it aligned just correctly, nothing else fits in properly, or some other situation where you need to do something in an exact way, or it will disrupt the entire rest of the process.
Very good. That's a great definition. What do you think the key point, and I'll make it easy for you up front, I'll associate it with an important step. What do you think the key point or important step was on your airplanes?
Fly.
That's more of like a quality control. Actually, I never told you to make a flyable plane. You all knew what to do for an airplane. You all started with something that was probably central. Huh?
Centerfold.
Every one of these has a centerfold. Common. They all have a centerfold. If there was a particular way we were doing the centerfold, it'd be in the key point. Hint, hint, there will be. All right. Makes the work easier to do. Having a knack or a trick, I want to take a moment to just be on a soapbox, and I'm going to try to give you a life lesson. Knowing how to be the person, that knows how to do a particular job particularly well does not give you job security in this world, right? A lot of people that I've worked with over the years thought having that knack or that trick on how to get a job done right is what gave them job security. Being able to express that trick or that knack to help everybody else do it right, that's where your value comes from. All right? So being able to communicate what that knack and what that trick is, that's extremely important. That is the whole value. I'd say a second value to these work instructions. The standardized portion is the primary value. The ability to communicate the knack or the trick to make it easier or to make sure that you make the job instead of break the job. That's very important. Okay? Next slide. All this job instruction, this is all documented. I could provide a 5 to 10 minute story for each one of these, if not many of them. But job instruction results in reduced training time, increased production, fewer accidents, less scrap, less rework, less tool and equipment damage, increased job satisfaction, improved quality, ultimately improved profits. I'll give you one story. I worked in something called the implant parts clean area. It's something like 14 different parts. And you had these implanters. They were about $2 million tools, all right? We had about 20 of them on the factory line. At any one time, at a best case scenario, we were running about 3/4 of them. All the time, there was either something breaking or there was some sort of preventive maintenance going on. So what we had decided over the years was there's these certain 14 parts that are the most frequent to either break down or be able to predict when they would go down. So we kept a parts clean room where the whole job of the parts clean people was to disassemble a part, clean a part, and reassemble a part. That was their whole job. All right? The disassembly had to be done in an orderly fashion, pretty easy. Now mind you, these parts, some of these were $1,000 parts. Some of them were like $10,000 and $20,000 parts that you're putting on the table, performing surgery on, rebuilding it, sticking it in its tool. Remember, it's a $10,000 part fixing a $1.5 million part, so these aren't like spark plugs or something, right? Our factory was the worst in 3 factories for being able to keep these parts up to production. So we applied this job instruction methodology to 8 technicians working across 4 different shifts, so 2 technicians per shift. We did an analysis, sure enough. They were disassembling everything in random orders. They were cleaning similarly, because their options were limited. But the reassembly, totally off the charts. Totally off the charts. Everybody was doing it differently. Everybody had a little knack for getting that screw in. And so all these parts, they were being put in. It's no wonder this tool stayed up 10 hours, this tool stayed up 100 hours, right? So what we decided was job instruction, everybody will do this way. Oh, Jim, you just want us to be robots. No, I want you guys figuring out what the best way are, what the best ways are to do this. I want you writing your work instructions and agreeing on the best way to do things. And then, as you can prove to me that that was the best way, then you can come back and use your intelligence. I do value your intelligence to make improvements. But we're not making improvements until we have a standard. I almost fired a guy at the very end. I took his certification away because he point blank told me and the group, this was a really good experience, but I don't agree with some of the decisions we made, I will be doing things for what's good for the factory. And I said, you're not doing things for what's good for the team, you're decertified. It's not what's good for a factory. Your way does not make something good for the factory. Doing it one way makes it good for the factory. He insisted his knacks and his tricks were the right way. You know what? In some cases, I'm sure I am. I'm not patronizing them. This is years later, and it makes me feel like I'm patronizing. I'm not. If he would have got with the program, his ways would have been included. All right? There are some stories in here where we beat that 25%. We did, in fact, do things, reduce training times by 25%, absolutely. Next slide. Meat sheet. This is nothing more than what's in front of you. I do want to give credit where credit's due. There's an awesome book out there called the TWI Workbook. I adapted 95% of this from them, so I want to give credit where credit's due. Next slide. All right, this is a bit complex, but I'm going to break it down for you. All right. What time is it?
10 o'clock.
I want to get some practice in first, and then I'll break this down. Next slide.
That's it.
Okay, that is it. So here's your instructions. You've got